So we've been discussing coordinate transformation. Okay. And what we discussed was transforming from ECI to PQW. Through 3-1-3 sequence by angles cap omega I small omega will yield this rotation matrix. R PQW with ECI is, so the first rotation is third rotation by angle cap omega. The second rotation is one and I, right? And the third rotation is three little, right? So the rotation sequence is cap omega, I, and small omega. But the multiplication sequence is the opposite. Okay. What is the fundamental rotation associated with this?
Right section.
No, the fundamental rotation associated with this.
That's the one.
Oh, you're talking about
C theta.
Cosine omega, right? Omega.
Cosine omega.
Sine omega.
Zero. Negative sine omega.
Right.
Cosine omega. 0, 0, 0, 1.
You got it. Wonderful.
Yes, sir.
And this is
it X?
0, 0, 1, or
1,
what?
0, 0, right? 0, 0. And this would be
Cosine omega,
I, cosine I.
I.
So angle is I, right?
Sine.
sine I, negative sine I.
Cosine.
Okay. And the final one
Across
is that again?
The same as the one on the left, but omega.
Okay. And if you solve for this, you're going to get, this is 3 by 3, right? This is 3 by 3. This is also 3 by 3. Okay. So the rotation matrix is on page 217. Okay? But if you multiply all these three together, you're going to get minus sine omega, cosine I, sine omega, plus okay. So this is your rotation matrix for going from ECI to PQW. Okay. Now, as part of your exam,
That would be given the bottom part.
right, I won't expect you to
Multiply that.
well, you may be asked to derive this.
Maybe.
It is not that difficult. It's actually not difficult if you understand. So think about this. How many fundamental rotations are there? 3, right? There are always 3 fundamental rotations. 1, 2, 3. And if you change the angle, you know the angles will change here, right? That's simple. Can you arrive until this point? The challenge would be to arrive at the last stage. Correct? This would be algebraically challenging. If you don't get this right, you may lose a point or two. But if you show me, if I give you sequence, angles, can you arrive until this point?
Of course.
Yeah. If the sequence changes to 1, 2, 3, alpha, so let's say this is 1, okay? The second would be, let's say again you're transforming from ECI to PQW, but you're using rotation sequence 1, 2, 3 sequence by angles alpha, beta, gamma. Okay? What will your R ECI to PQW look like in this case?
1, 2, 3.
It will be 3, 2, 1. Right? So you have R 3 gamma, right?
You write it back.
R 2 beta,
Oh, you do right back.
R 1 alpha.
And you multiply it, 1, 2, 3, right?
You write it as 1, 2, 3. You multiply 3, 2, 1. You get the sequence is 1, 2, 3. You see? But the multiplication sequence is 3, 2, 1.
Okay.
Does that make sense? So you can write this and you can write this as well, right?
Right.
Cosine gamma
Sine gamma.
sine gamma
0.
0 minus sine gamma
Cosine gamma.
cosine gamma
0.
0 0 0 1. This would be 0 1 0 0 0 cosine beta minus sine beta, right?
Sine beta.
Sine beta and cosine beta.
Yes, sir.
And then the final one is the same as it's 1
0.
0 0
0.
0 0, right?
Right.
And then you have cosine alpha
Sine.
sine alpha minus sine alpha.
Cosine.
So what you get here, the next step will be only a few points. If let's say this whole thing is 10 points, I may take off
0.5.
1 or 2 points if you don't get it. I cannot take partial 1/2 point, right?
Say that.
If you don't give me this at all, you lose 2 points.
Okay.
If you make an attempt, give me a few of the cells to be okay.
So that should be right.
Then
Then
the
I'll
bonus, you get it all right.
If you get it all right, you get all points. Is that fair?
Plus 1. That plus 1 point. That's a good bonus point there.
It's split.
Hmm?
Split, that's a split.
It's a bonus.
Just 1 or 2 points, right?
Like
If it's a 10-point problem, so you are getting all of your 8 points for identifying the sequence, writing it in this order, writing the fundamental rotations, right?
And then plus 2.
Hmm?
So it's out of 8. So 8 points. And then you get plus 2 points if you get that all right.
So is this clear?
Is the matrix calculator allowed? Matrix calculator allowed?
If it is, can you do algebra in your calculator?
Yeah.
I would not advise you to do algebra in your calculator. Okay, I would really want you to do the algebra. Okay. So we'll do an example and see how this is useful. All right.
But wait, hold up. That's not how the actual problem is. That's not how the actual problem is.
This is not an example. This is just a derivation. This is just a formulation. Examples will be sequence and numbers here. The angles will be numbers, right?
Hey, so I know this kind of correlates with homework problem 6 and 7.
Yes,
So I was trying to say, like, can we do one of those?
Right. So it is.
That was like the last one.
The last ones, if you reference it to the old textbook, I think that's what it is.
Okay.
Alright, so we'll take a look at this. Okay. So is this clear? There are.
Hold on, right? So, sorry, to go back to what you previously said, you said for a group problem, we would have numbers, but do you mean angles? So like, would it be cosine 30 degrees or something?
Right, yeah.
Would you want us to actually have like the numbered values inside our matrices, or can we leave it as the angle?
And the number,
Oh,
Okay, so either or no, the numbers, not the angle.
if it's a numerical in that sense,
mm-hmm.
you will need to arrive at this. See, numerical arithmetic you can do it in your calculator. If you input these three matrices in your calculator, it should give you this.
Dr. Asandi, can you explain how you did that math? How you got those values? I'm just confused.
So I'll do this and this. Okay. So forget about this. Okay. This is another sequence. Alright? Don't forget about it. This is another sequence. So there are, I just want to finish, or I just want to mention here, you see this is a symmetric sequence, right? How many symmetric sequences can there be? How many fundamental rotations are there? Three. So how many symmetric sequences can you get? Huh?
You never get one. Probably. 1, 2, 3.
1, 2, 3 is not a symmetric sequence.
2, 2.
This is a non-symmetric sequence, right?
Just 3.
It can be one. No, it can be 1,
2, 2, 2, 2.
You cannot repeat.
You can't do. Then it's gonna be 3, 4, 6.
1, 2, 3, 2, 3, 3.
6.
6.
3, 1, 3. Okay. 3, 2, 3. 1, 2, 1. 1, 3, 1.
2,
2, 1, 2. 2, 3, 2.
So 8.
6.
6.
6 sequences. These are the non-symmetric sequences. How many non-symmetric sequences?
A lot.
You
never see.
No.
No, there are only 3 numbers. There are only 3 fundamental rotations.
2.
You cannot repeat.
2.
Huh? You cannot repeat 1, 1, 2. You cannot do that.
It should be 2. Because you do 1, 2, 3, and then 3, 2, 1.
What about 2, 1, 3?
That's not.
Why not?
Oh, I forgot what you said. You said.
Or
you said
three
repeat.
combinations?
You said not repeat. I know it's like it's like
I think
what's it called? It's like who knows?
6.
6 again.
It is again simple. Okay, 1, 2, 3.
Right.
What is the other one starting with 1? It has to be 1, 3, 2, right?
Oh, you can.
There cannot be anything else. You agree? Anything starting with 1 is what? 1, 2, 3 or 1, 3, 2. Can there be anything else? There is no 4. Right? 1, 1, 2 is not allowed. 1, 2, 2 is not allowed. You understand?
What kind of sequence is that?
Non-symmetric sequence.
Non-symmetric. Okay.
So you have 1, 2, 3, 1, 3, 2. 2, 1, 3, 2, 3, 1. 3, 1, 2, 3, 2, 1.
So 6.
6. 6 non-symmetric sequences. 6 symmetric sequences. There are 12 sequences. So these are called Euler angles. Okay? And the sequences are called Euler sequences. Strictly speaking, this is what Euler discovered. That if you are in the ECI frame and you want to go to the PQW frame, these angles have significance, right? You know what these angles are?
Yeah.
What are these angles?
That's the
Huh?
right ascension.
Right, this is the right ascension of ascending node. This is the inclination. This is the argument of parity. Right? So if you are in the ECI, you do a 3-1-3 rotation by these angles. You get into PQW. You get it? This one has a physical significance. This one doesn't. This alpha, beta, gamma. Do they have significance? In the orbital mechanics, they don't have any significance. See, only this sequence has a significance. All the other 11, they are just mathematical combinations. Does that make sense?
The doctor, something.
Can you show us how to get like that first?
Yeah, I'll do that. So next step is, I'll do this, okay?
Okay.
Only these two.
So doctor, something. How do you
Alright.
know? How do you know what sequence to use?
You don't have to. So if you change the sequence, the angles will change.
Okay.
You understand? So you can get from here to here. How many ways can you get from this to this? 12 ways. If you, depending on what sequence to use, your angles will change. But for 313, the angles have specific names.
Okay.
All the 11 other sequences, angles don't have names. They are just mathematical combinations.
Okay.
Does that make sense?
Mm-hmm.
So here, how do you multiply these two? You do row, column, right? So you're going to get, the first one is as it is, first matrix. The second two,
One times cosine.
right, you get cosine omega.
And the rest is,
Anthony, you need to pay attention, okay?
Just look down perhaps.
So because you're asking, so 1 into this,
the rest is
this into this, this into this. You get it?
Yes.
So only cosine omega remains. 1 into cosine omega plus 0 into this plus 0 into this. Alright? This is that element. Now, let's look at this element. First row, second column. You have 1 into sine omega, 0, 0. Right? This would be sine omega.
Okay, so you multiply the row by.
Yeah.
Got it.
This row into this column. 1, 1. That will be 1, 1, 1. Does that make sense?
Yes.
1, 2. 1, 2. 1, 3. 1, 3. You see it? This is row, right? First row, first column. This is the element in the first row, first column. Does that make sense?
Yes.
First row, second column. This is the element in the first row, second column. Right? So that is how you do it. Second row, first column. Where is the second row, first column? This. So it will be cosine I sine omega. 0 into this plus cosine I into minus sine omega. Right? Sine I into 0. Second row, second column. 0 into this. Cosine I into cosine omega. So this will be cosine I, cosine omega. And then 0. Okay? Finally, second row, third column. You get sine I. You got it? So third row, first column. Where is the third row, first column?
0.
You see why I say third row, first column. Why is this element third row, first column? Everybody understands that? Everybody understands the correlation. What element is this? How do you define this element? First row, first column. Right? So you see what I'm getting is first row, first column.
Dr. Sunday,
Hmm.
you said that you multiplied by 3, 2, 1, right?
Right.
But you're multiplying the bottom, the bottom.
Once you write it in that sequence, it doesn't matter how you multiply.
Does it?
It doesn't matter. The sequence is what matters. So even if you multiply these two first, and then multiply that by this, you get the same answer. You cannot shift it and get the same answer. You cannot put this here, and expect to get the same answer.
Or really saying that you're doing 2 times, well, you're doing 3 times 2 actually.
Right. So I'm
I
doing,
mean, you're doing 1 times 2 when it normally would go to the left and then to the left.
it doesn't matter. Once you write it in that sequence, you can multiply this by this by this. You understand? It is ABC. Okay? You can do AB into C or BC into A. It doesn't matter. Don't shift it, that's all. You got it?
Yeah, so you can multiply the third matrix by the second matrix.
Yes. Yes. That's what it is. So if you do that, then it will be this row into this column. You see that? So that is not, matrix multiplication is not, it's not commutative. If you flip it, you'll get a different answer. Okay. Anthony, got it?
Yes, sir.
So finally, this one would be
Would be 0. Wait. Should be 0, yeah. That first one should be 0.
I'm going to make you run. Do it properly.
Come on, man.
Third row, first column, so it'd be 0.
Huh?
E 0 times cosine theta, or omega.
Keep going.
And then negative sine I times. Or wait.
I just explained to you the process.
And I'm.
Yeah, then do it. Don't say it is 0. Don't guess it. Here, come here. See, this is your problem. You're guessing and you're not going through the process. You're not. So otherwise, you wouldn't have gotten 0.
You're alright, guy.
Yeah.
You can do it. So it'd be third row, first column.
Okay. Yeah, do it.
Okay. 0.
Mm-hmm.
What's this?
Wasn't it?
Okay,
You have to keep going.
There it is.
It is this into this plus this into this.
Oh, okay. I missed. Okay.
Okay.
Okay. So then it'd be sine squared or sine I.
Okay. You got it now? Do this. Do this one.
Okay. So
What are you doing?
we're gonna miss that one into that. Right? That's right.
No. It's
Where am I?
And then you put that right there so you
this.
Third row,
get
third column, second column.
Right. So this is third row, second column.
Okay.
Do it
So-
one element at a time.
Okay, so second, so that times
Hmm.
that.
No, man. It is this into this. This into this.
Oh,
This into this. You see, corresponding elements.
yes, sir.
Okay. So it is cosine omega.
Third row,
There.
or should be cosine.
That's one.
Is there anything?
No.
All right. You guys clear on this?
So, you're multiplying instead of adding? You're multiplying instead of adding?
No. You add. Guys, pay attention here.
Just make sure.
This into this
Right.
plus this into this plus this into this. That is this element.
Okay.
You got it?
Yep.
You should know this.
You do?
Okay. And this is the reason I don't want you to do calculator-based algebra or MATLAB. All right. So is this clear? So if you multiply this, see now you see this element coming through.
Yeah.
You see cosine omega, cosine cap omega, right? That is this element. You see that? Plus sine omega into cosine I sine omega, which is this element. Okay. You done?
Hello.
So let's look at example 4.7. Okay? And see how this is useful. So you're given, guys, pay attention here.
What page is that on the back of the side?
Joshua and Joshua, turn this side. So you're given age is equal to, it's on page 218, okay? 80,000. E is equal to 1.4. I is equal to 30 degrees. You need to find R and V in ECI frame. Okay? Now, solution. The first thing you can do is very simply you get this, right? Everything is given here if you use this formula, right? Even mu is known. If what does the if we know the orbit, now see if this makes sense. Guys, look at it here, okay? I make this a vector. My x component is, or t component is cosine theta. Q component is sine theta. W component is 0. Does this make sense?
No.
You see, this is my orbit. You with me? What direction is this? Perigee direction, P, right?
Yep.
This is?
Oh, that's the.
That's the focus.
Oh, based on Charles.
This is?
Not the,
What direction is this?
that's
Q.
Q. W is coming out, right?
yeah.
You get it? So if this is R, you can take R anywhere. Let's say this is where the satellite is. This is theta. You understand? This is R. This R is in PQW frame.
Right.
Does that make sense?
Then why do we know it's a PQW current? Why do we know that that's a PQW current?
So this R, if you see, what is this R? Simply the distance, right? This distance. You get it? If you quantize it in PQW frame, this is the PQW. PQW frame is what? The orbital frame. Perifocal frame. P is in this direction, Q is in this direction, W is coming out. Assuming the satellite is orbiting like this. If the satellite was orbiting like this, W would be going in. Okay? You see? P, Q, W. Alright? So here, this is R. What is the Q component of R? This is the Q component of R. You with me, Michael?
R.
This is R sine theta, right? This would be
R cosine.
R cosine theta. This would be the P component. And what is the W component?
W would be R cross R cosine cross R sine.
There is no W component. This vector is in this plane. It doesn't have any component. You get it?
Yeah.
It's like this. You understand?
Yeah, I get what you're saying.
It doesn't. If it was like this, it would have a W component as well. Since it is in that plane, it doesn't have a W component. You see, R cosine theta, P component, R sine theta. This is R, right? W component is 0.
Oh, okay, I see what you're doing.
So now this has to be in PQW. You with me? So I get my R PQW as this is my vector.
Is it given? Is it given?
No, I calculate it. You see, H is this, right? Mu will be given to you.
Mu is the radius of whatever, right?
No, gravitational parameter.
Huh?
Gravitational parameter.
Gravitation.
Mu is gravitational parameter for Earth. Okay, this is the Earth orbiting satellite. Theta is given to you. 30 degrees. This is 30 degrees. E is given to be 1.4. What orbit is this?
What's this? Said the order. Oh, you're talking about
What
order?
kind of orbit is it?
This is elliptical essentially too.
Is it elliptical?
This is a hyperbolic.
It's a hyperbolic.
For that vector times your two body are you plugging in 30 degrees in the cosine theta, sine theta? Okay. And then you're just multiplying what you found time.
Whatever you find here, you multiply this by this by this.
How come you're setting up like an orbital orbit and you're kind of deriving those functions from an orbital instead of how you're going to do it?
It doesn't matter. So even in hyperbolic orbit, this would be the p direction. So if I just erased this,
Yeah, we have it on.
it may look like a hyperbolic orbit.
But we can only know, we can only switch.
Yeah, only on this you know what kind of orbit.
Right, you're saying, but when you're trying to transit from PQW frame, you can only do that up until it gets past the, or half circle, per se. Like you couldn't figure out once it gets past a certain point, right?
Yes. So it's only relevant at a certain point. Okay, it is once it has escaped, so it is in a hyperbolic orbit around Earth. All right. Once it has escaped, we don't know, right? We have to figure out something else. We do propagation. You got it? So until this point, you can see this is hyperbolic orbit. So if I just draw something like this here, this becomes a hyperbolic. You got it? So you get this, you can calculate this, right? But what is asked of you? It's ECI, right? So you need to write, by now you know this, right? You know how to write this. And what is this? Now keep in mind what we discussed just before this. R we discussed this, right? To go from ECI to PQW, you do 3 cap omega, 1 I, 3 small omega. What we need is the other way. We're going from PQW to ECI. Okay, so this,
You know all of that by how it's like written above? You know that from how it's written above?
what do you mean?
Like, you see how like before
This one?
said we did it the other way? Yeah, because it's written different, that means that's what we have to do the other way? Yeah. Okay,
Right,
alright,
the notation, yes.
yes.
Okay. So what we need is PQW to ECI. We know this, right? We can calculate this from this. You see? Is this given to us? 3 you know, right? Is omega given to us?
Yeah.
So you know this matrix, right? I is given to you. You know this matrix. This is given to you. You know this matrix. So you'll end up with a 3 by 3 big matrix. But that is ECI to PQW.
Are you going to take the inverse of that to get the...
You have to take the inverse typically. Yes. But what we do is, in this case, the transpose suffices. What is the difference between transpose and inverse? What is it? How do you take the inverse of a matrix?
Well, we just set everything 1, 0, 0, 0, 1, 0, 0, 0, 1 on the right side and left side of the reduction. Right? Is that what you're talking about? You can do it that way too, though.
The inverse.
I'm saying you can do it that way too.
Isn't the inverse like this? Whatever it is.
Transpose, how do you take the transpose?
Or you can turn the column to rows.
Yeah. Okay. Inverse, you do the cofactor matrix
Oh, yeah, you can do that way too.
and divide that by the determinant.
It's not good.
Okay.
You said you
Don't worry about it. Just focus. I think this is, let's keep it simple. But you inverse and just know that inverse and transpose are different. Transpose is, here you just need to do a transpose.
okay, we get the same answer?
Huh?
You
Yeah, so
transfer
you just put, if you put this here, you get your, you know this, right? You calculated this.
Mhm.
You calculate this and take it, transpose and put it here. You got it? You get REC. Does that make sense?
Yes, sir.
Okay. This is one of the topics for the next exam. Where do you want your next exam? Next Friday?
No, so let's wait till after.
Yeah, that's we get our test back.
After Thanksgiving break for sure.
I don't want you to take after, I want you to have a good Thanksgiving break.
We should have a
What?